And there are different ways that you can write it out. So this says, write the ways that an isotope of uranium atom, with a mass of 232 can be notated. Well, let's go find uranium because you may not remember like what the symbol is for it. So on the periodic table, I'm going to look around and find it. Let's see. It's going to be down here. Looks like it's right here, and you can look at it up right here as well. Uranium's symbol is U. At the bottom here, I can see the overall average atomic mass, but that doesn't really help me in my specific case. But this number always stays the same. So uranium's symbol is U, and its atomic number is 92. So I'm going to go over here and I'm going to write that down. So uranium symbol is U, and its atomic mass is 92. So let's write out all the ways that we can notate that. So we can write uranium, and then this is where its mass is right here. This is the mass. So one way we could write it is uranium-232. You do not put the proton number after the dash. This is just kind of helping me understand a little bit about uranium, but you don't put that after the dash. So we could write uranium-232. We could also write it a little bit simpler if we're lazy and write U-232 because U stands for uranium. Let me think of some other ways that they want you to write that out. And there is one other way that we can write it, and I'm going to show you that in the next picture here. It's called isotopic notation. These are really the two ways that you can write it, and then there's one more way called isotopic notation. So we'll come back to this. So isotopic notation is when you put the symbol here. So like X would be the symbol of the element. So uranium is U. And then at the bottom, you put the proton number, and at the top, you put the specific mass number of that specific element. So in this situation here, for this is carbon, right? C is for carbon. And isotopic notation, the number down here is the atomic number. The atomic number. That's how many protons, right? That's how many protons it has. Remember that on a normal periodic table, that's what's at the top. So it's kind of weird, but in isotopic notation, you put it at the bottom whenever you're specifically doing isotopic notation. And then this up here is the specific mass number of the specific element we're on, not the average mass overall that you see underneath the element on the periodic table, but the specific mass for this situation. The mass number, which remember is protons plus neutrons. So this right here, the 6 is the number of protons, and the 14 is the total mass. If I wanted to figure out the number of neutrons, I could just subtract those two. I could do 14 minus 6, and if my math is right, that should be 8. I'm really bad at subtracting sometimes. 13, 12, 11, 10, 9, 8. Yes, 8. That should be 8 neutrons, right? And I know that because 8 plus 6 makes 14. Protons plus neutrons. So you can figure out the neutron number by subtracting top from bottom. But this is what isotopic notation looks like. So if we want to put uranium in isotopic notation, we need the symbol right here. And remember, the proton number now goes on bottom. And we figured out the proton number from the periodic table. You can go look it up. It's the number on top. The proton number is 92. And then in our specific situation, the mass number is 232. If you look on the periodic table, the mass of uranium, it actually says 238.03. But that is the overall average mass of the entire, like of all of the uraniums in the world. Some of their masses are different because they all have isotopes. The proton number at top never changes. But the mass number is specific to that element. And so ours is 232, even though the overall average is 238. So we have one more example here. So I just wanted to break down like what information is this? What can we glean from this? So when we look at this element right here, let's figure out what the name of it is. Okay, what's the name of this element? Well, we could go to the periodic table and find that element, find Cl. So we need to look here and find Cl. Okay, I see it right here, and you can look right up here. Cl stands for chlorine. its atomic number is 17, and its overall average mass is 35.45, but that doesn't really pertain to our specific situation because it's the overall average. But its atomic number is 17, and it stands for chlorine. So its name is chlorine, right? Its atomic number is 17. And we can see that from right here as well, right? The atomic number is always what's on bottom for isotopic notation. So the number of protons here, if I asked you how many protons does this have? The answer would also be 17 because the atomic number is the number of protons. It's the same thing. If I asked you what is the mass number of it, what is the mass number? The mass number would be 36 because the top represents the mass number. You do not look at the average mass in the periodic table when we ask you for the mass number. You look at the picture and you look at what's on top. If I asked you for the number of neutrons, you could subtract, right? Because this is the mass and this is the number of protons. So if we take the difference, we could get the number of neutrons, right? So we could do 36 minus 17. So that would be 36 minus 17, which would be 19 neutrons, right? And if I asked you to rewrite this, the other formatting, the other way, we could rewrite this as chlorine dash 36. Remember that when you write it this way, after the dash, that's just the mass number. It's not the proton number. So it tells you the overall mass number there. The last thing from this lesson that was kind of a random tidbit of information is IUPAC naming. So whenever an element is brand new, like sometimes we discover new elements. So you can actually see these elements that are in gray right here took a long time to name. And for a while, they didn't have names because like all these people have to get together and vote on what the name is going to be. And so it's like really official these days. And so when we're in that voting process, we call it by its IUPAC name as like a temporary placeholder. And the way it works is you look at the element the element atomic number. So if the atomic number was 120, you would name it according to these numbers here. So the number 1, you would write un for the number 1. For the number 2, you would write bi, right? And then for the number 0, you would write nil. And then you can kind of write ium at the end regardless, un bi millium. So something like that. And so you just break down the numbers according to this chart right here. Okay, you can also look up IUPAC naming, and you should get a chart like this. And then you put ium at the end. So for example, if it was the number 119, we would do un, because 1 is un, right? And there's 2 ones. And then 9 is in ium. And then you kind of just squish all the words together, un, ium. It's kind of a weird thing. So that's how you name with IUPAC naming. And these are the main things from lesson 1 that you need to know. And if you have any other questions at all, please feel free to join my classroom and I'll be happy to help you. Have a great day.